could get really specific about exactly what comes back from DynamoDB. I could test things like if an attribute in my item has a different name than I'm expecting, or maybe it's a Boolean and I'm expecting a string. So there's a few different variations that I can test using this TestConnection method, and it's really valuable for getting really specific with the AWS responses. Hello everyone, and welcome to another video on building serverless applications on AWS with Rust. In this video, we're going to have a look at unit testing and the different strategies available to you to allow you to test your serverless applications locally without relying on connections to actual AWS services. And this allows you to really focus in on the business logic of your application. And there's a couple of options we have for testing some of the AWS SDK calls. Let's get straight into it and have a look at how we can test things like our SDK for DynamoDB. And this example is following right on from where we left in the last video. Again, that will be floating around up here somewhere. So as a default, we've got this set of tests in the application that came from our SAM init command, and this has a test built into it. And because of the way the SDKs are generated for Rust, there's actually some really useful structs we can use to help simplify our testing. And one of these is this TestConnection struct. And what the TestConnection struct allows us to do is actually generate a dummy request and response that will happen when we make the call to DynamoDB. So you see here, we're creating a sample request to DynamoDB. In this case, the table name is test, and we're passing in an item and a payload. And we're saying for this connection, return this response. So we're going to dummy a 200 response and also some results that are actually going to come back from DynamoDB. So we're mocking out DynamoDB here using this TestConnection. And then when we actually create the configuration for our DynamoDB client, you can see we're actually passing in this line here, we're passing in our dummy connection as part of the SDK configuration. And then of course we need to pass in some credentials, so we just pass in some dummy strings here. And now we've got this SDK config object. So when it actually comes to us initializing our DynamoDB client, we're doing that from configuration, and we're generating some mock config, passing in our test connection. And then of course we can go off and mock some API gateway requests. So we're just building out an API request here. Remember, our create request, our put endpoint, takes a path parameter of ID, which is what we're creating here. And then we're actually building out our HTTP request with the method and the URI and the body. And then here we actually make that request using our put item function, the same function that our Lambda runtime is going to use when our function gets invoked. So now that we've got this response, we can then use the assert equals macros just to check that what comes back actually matches what we expect. So we expect a 200 status and the body of the response to read item saved. And if we look back up at our actual function here, our actual handler, you see we've got our item saved response and a 200 if DynamoDB returns successfully. So let's add a second test now and test how we would handle DynamoDB returning an error. So we want to actually test this code path here. So if we come down to the unit test now, and I'm just going to duplicate this put item test that we already have. So let's just take a copy of that there, and we're going to call this test put item when DynamoDB fails should return 500. So all we need to do to test this is when we build out our test DynamoDB connection, we can simply pass in a 500 as the response that comes back from Dynamo. So we're saying Dynamo is going to return a 500. How is our application, our business logic going to cope with that? How we expect that to cope with that is that our response that comes back is going to be a 500 response, and we are going to expect our message to be internal error. So let's just grab a copy of that from there, and that's what we expect our response to be there. And let's just give that a try now. So if I scroll back up, and I'm just going to grab the name of this function so we can run that test on its own, and I'm going to run cargo test, pass in the name of our test, and cargo is now going to go off and run our test. And you see we've got one test result and one test passed. Excellent. So we've added a new test there. If we were to change, for example, the response that gets returned here to say there has been a problem, and we rerun that test again now, we would expect this test to now fail. And you can see we've got an error back here from our test run, and we actually get a really useful message to say that the left-hand side of our assert was there has been a problem, and the right was internal error. That's what we expected. Let's just put that back to how it was, back to internal error, and we've now got two tests. So we're both testing here if there's a successful response from DynamoDB and if there is a failure response from DynamoDB. And we're doing that by creating a test connection that has some hard-coded requests and responses. Now, this is really useful, and this is a really easy way to get started, and it's awesome that AWS has provided this test connection thing that we can use to test different variations. But there is an alternate way to test your serverless applications with Rust, and that's using the Mockall create. And Mockall allows us to really easily mock out traits and things that we have got in our application. So you can see here, I've got a sample trait called my trait, and I can just add this auto mock attribute. And when I add the auto mock attribute, I then get this mock my trait object that gets automatically generated by Mockall, and I can then use that to say, what do I expect to happen? How many times do I expect this mock to be called? What do I want to return? So I can use this as a way to a bit more simply mock out some of our requests. So how can we use that in our application code? Well, what I've done before this video is I've moved some of the data access logic into our shared library. So we now have this trait called data access, and you can see I have the auto mock attribute already assigned to my data access trait. Quick side note, async traits aren't currently supported in Rust, so I have to add, as well as adding my Mockall dependency, I also have to add this dependency to async trait, which allows me to create traits that are asynchronous. Let's go back to our library code. So we've got this data access trait, and you can see I've got my implementation here of a DynamoDB data access struct. And in my implementation, I've got my create method, I've got my get method, and I've got my delete method. And this is where I actually have the DynamoDB code to interact with the service itself. I've also got a new implementation to allow me to create a new instance of my DynamoDB data access struct. So let's go and have a look at that in our actual application code now. If I go off to my get handler, you can see when I initialize the function here, as well as creating my DynamoDB client and my table name, I'm also creating a new instance of this DynamoDB data access struct, passing in my DynamoDB client and my table name. And then when I've actually got my get item function, my actual business logic, that actually takes in a generic parameter of type T, which is a data access. So the value I pass into this function needs to implement my data access trait. And then this actually dramatically simplifies my Lambda function handler, because instead of having all that DynamoDB logic bundled in with this same code, I'm just calling data access.get. And then I can just parse out my response here. And all of that complicated logic, interacting with DynamoDB attributes and pulling out the right payload value, that's all abstracted away now, and this keeps my handler nice and simple. If we actually go and look at the tests I've got here now, and remember, in my library file, I have added this auto mock trait attribute to my data access trait. So in my tests now, in my get handler, you can see I can just create a new instance of this mock data access struct. And that actually comes from my Rust sample crate. But I've not created a mock data access struct anywhere. This is auto-generated by Mockall. And what I can say with my mock is that I can say I'm expecting there to be a get, and that get is going to be with a parameter of this test ID value here, which is 1, 2, 3, 4, 5. I expect my get request to be called once, and when it gets called, I want it to return a string that just says sample payload. I'm just going to hard code that response that comes back from my mock. And then again, the same as in my create test, I'm just setting up my mock API gateway request and creating the parameters that I need. And then I'm simply calling my get item handler. Again, this is the function that my actual Lambda function is going to call. And then the same as in my put item test, I'm asserting that the response is going to be a 200 and that the body of my response is of course going to be sample payload. So my business logic currently is just taking the value from DynamoDB and just returning that straight back to the caller. So because I've set up my mock to return sample payload, that will also cause sample payload to be in my response body. That's what I'm expecting to happen based on my current business logic. So if we now wanted to test, again, we wanted to add a error case to test for errors. Let's say test get item with data access, error should return 500. If we go and look at our business logic, we're saying if there's an error, again, we just want to return a 500 status code and a message of internal error to our caller. So how would we do that? Well, in here, in my test for the error, instead of returning an OK message, I can simply return an error. And actually, the contents of that error don't particularly matter. I'm not doing with them currently, so I can just return an error. All of this stays the same, the request stays the same, and all that's going to change is I'm now expecting my status to be a 500 and my message to be internal error. I think that was internal error. Let's just go and double check that. Yep, internal error. So what I've done there is I've said I want my mock to now return a error, and then I expect my response to be a 500 and the body to be internal error. So again, let's go and run that individual test. Where's the method? There we are. If I come back to my terminal, just clear that out, and I'm going to run cargo test and pass in the name of that individual test. Now, if you look at the actual test logic here, this is an awful lot simpler than what we have in our create handler. If I just open up the two side by side now, let's just right click there and open to the side. There we are. If we look at these side by side now, if I get my test method over on this side, and then I get my test method here. See, within our create test, we need to initialize this test connection. We need to create our client, and that create client call comes from this get mock config function. So there's a lot more going on, whereas at this side, I'm just creating a new mock data access trait, and I'm just configuring what I'm expecting to happen in this test. If we come back to our terminal window now, we can see that that test passed successfully. So there are the two options that you have available for testing your business logic of your serverless applications without needing to rely on them external dependencies. These are unit tests in the truest form. Now you might want to use the SDK-based method if you are testing any of the AWS SDKs, because it gives you a lot more control over the actual response that comes back from the AWS service that you're interacting with. So you can see here, when I'm interacting with DynamoDB, I could get really specific about exactly what comes back from DynamoDB. I could test things like if an attribute in my item has a different name than I'm expecting, or maybe it's a Boolean and I'm expecting a string. So there's a few different variations that I can test using this test connection method, and it's really valuable for getting really specific with the AWS responses. The danger here is that if the DynamoDB API changes, your test then isn't testing the true response from DynamoDB. So that's just something to bear in mind. Whereas abstracting some of your SDK calls behind some kind of trait, which, as well as being a good practice to allow you to change your implementation easily, it also simplifies your test logic and allows you to really simply, easily set up your test logic that's a lot more readable. You know, I can see here that I've created a new mock. I'm expecting a get with a test ID passed in it to be called once, and it's going to return this. So this method can be a lot more legible, and it also is useful for testing things that maybe aren't AWS SDKs, where they might not be that easy to get started testing built into the crate itself. That's all for unit testing. If you've enjoyed this video, as always, please like, please subscribe. I really enjoy hearing from you. So if there's anything else you'd like me to cover in these Rust videos, please reach out and let me know. And I will see you all next time.